Today Morgan and I are going to teach you about bin packing. There are many different types of bin packing. Some include next fit, first fit, best fit, worst fit, next fit decreasing, first fit decreasing, and worst fit decreasing. We're also going to teach you about vertex coloring.
Okay. Okay, for our first example we're going to be doing first fit. Each bin and each individual square is a bin, has a capacity of 10. So first we're going to take 6 and put this in the bin, and we're going to put 6 in here because the 6 does not fit in here because of the capacity. 5 does not fit in as well, so we can do another 5. And we're going to keep going, but one thing we need to remember is when we're going down the list, we can go back to the beginning box. For this 4, we can put it in the first box because then we do have 10, making this box full. And with this next 4, we can put this 6 in, or this 4 in here as well, making that box full. We can do 4 and 2 and 2, making that box full. And then we keep going with the data until everything's complete and in order.
Next one we're going to do is next fit. And for this one you have to fill in every bin, and if it doesn't fit you have to go to the next one, but you can't go back to the previous bins. So for the first one we put the 6. And same with the next one because it can't fit into that one. And 5. And because we have a capacity of 10, we can put the other 5 in. And then 5 again. And next one's a 4, so that can go into this one. And then you just keep going until you fill them up. You just have to remember you can't go back.
Alright, for the worst fit, for the bins, we're going to put the 3 in here. And the 6, and now we only have 9 in there. So then we're going to do the 2 and the 5, and the 3, leaving us with a full bin. And then we're going to have the 4 and a 4. We're going to put 4 in here, but then with the 1, we don't put it in here because that doesn't have the most room left. This bin has the most room left with 8, so we'll be putting it in there with a 9, and then we'll be moving here to 2, so then we have 6 in here now, so we'll be putting another 2 in here because it won't fit in any of the other bins, and we'll be also putting another 2 in here, so that for these just keep going on and so forth, making sure that each bin is the fullest it can be, but you also want to be filling the ones that are the least fullest, and that's the worst fit bin packing.
Okay, our next one is best fit, and for this one you don't have to worry about the order, and you have to find the perfect matches for the bins, and the capacity is still 10. So we're going to start with 6 and 4, because that gives us 10, and another 6, and 4, and 5 and 5 go together, and another 5 and 5, and then we have a 7 and a 3. So you just keep going down the list to find the matches, and then just fill up the bins so they can get 10. Go.
Alright, for our next example, or next learning target, we're going to be doing next fit decreasing. This is the same thing as next fit, except for you just have the data organized in a decreasing order. So all you do is, for the first one, 8, 8, 7, 7, 6, 6, and then 5, 5, 5, 5, 5, 4, 4, 4. And so on and so forth until the data is complete. This is really simple once you get the data in order, and all you really have to do is, the only time consuming thing for this is getting the data in order. Otherwise, it's fairly simple. It's just putting the data in boxes as long as it doesn't exceed the capacity of the box.
Our next one is first fit decreasing, and you're just going to put the data in order again. And then whenever there's room, you just put the next number that can fit into the same box. So we're going to start off with the 8s. And then just keep going because it exceeds the limit. And then the 5 and the 5 can go in the same box to get 10. And then the 4 can go with the 6s. And then because it can't fit into the 7 or 8, you have to start a new box. And the 3s can go with the 7s. And the same with the 2s can go with the 8s. And then there's 2 more 2s that can go with the 4s. And that would be first fit decreasing.
Alright, our next one's going to be worst fit decreasing. For worst fit decreasing, it's the same as the worst fit method, but you have your data organized again, and then you just fill it in. So the 8s go in, 7, 6, 5, and 5. That leaves that box full. 5, 5, 5, 5. That's all full. And then we're going to go back with the 4s, go in the 6s because they have the most room available. So then those 4s are out. With the remaining 4s, we make new boxes, and those are out. The extra 4 can go in here because that's where the most room is and won't fit anywhere else. After that, we have a 3, and the 3 is going to fit with the 7. Because that's where the most room remaining is besides the new box. Then we're going to have another 3 with the 7.
Stop. So now that we concluded bin packing, we can move on to vertex coloring. Vertex coloring, you get a graph, and each edge that connects to a vertex can't be the same color as the next one. So for example, we'll start with A. Because A connects with E and B and F and C, we can't have any of those be a circle. So we'll put F as a square. And we can also put B as a square because F doesn't connect with B at all. And then C, we could do a triangle. And then we can put D as a circle too, because it doesn't connect with A at all. And then E can also, and then E has to be different from F, D, C, and A, so we're going to make it a star. And then we have to do the chromatic number, which is how many different colors or shapes you have. So for us, we have 4 different ones. So we have the square, circle, triangle, and the star. And that's all for vertex coloring.
Alright, everyday examples of bin packing are around us. If you look at when you pass a FedEx truck or a UPS truck moving product from one location to another, as my aunt does in Atlanta, she ships out hubs and stuff, they have to have the right amount of goods on each truck, but it can't be overloaded with weight because, say it has a 2,000 pound weight capacity, they simply can't overload that and exceed that. So sometimes they only may put 1,800 pounds in that because they don't want to exceed it, but they can put the most product in it. Other times they might want to put 2,000 pounds worth of stuff in it,